Today's lesson is about factoring. Factoring is a method that we can use to solve quadratic equations. And remember, the solution to a quadratic equation is where the parabola touches the x-axis. For this method, we are looking for two factors which multiplied together equal the original polynomial. So for example, when looking at the number 24, I can break that down into two factors, 6 and 4. Those are factors because when multiplied together, they equal 24. The same applies for polynomials. When looking at the polynomial x squared plus 8x plus 12, I can break that down into two factors, x plus 2 and x plus 6, because when multiplied together using the FOIL method, I get x squared plus 8x plus 12. When talking about factoring today, we're going to look at three different methods: trial and error, the difference of squares, and the perfect square trinomial. First up is trial and error. Trial and error is a great method for when the coefficient of a is 1. When the coefficient of a is something other than 1, things get more tricky. Let's look at the first example. In this example, we will be looking for two numbers that which multiplied together equal 16 and when added together equal 10. Let's begin by looking at the factors of 16. I've got 1 and 16, 2 and 8, 4 and 4. Now, when actually starting to factor, I know that my first two terms will be x, because when multiplied together, I get x squared. Now I need to determine which factors add up to be 10, and that would be 2 and 8. So I put 2 and 8 into the boxes. Now, checking with the FOIL method, I know that x times x is x squared, x times 8 is 8x, 2 times x is 2x, and 2 times 8 is 16. When the middle terms are put together, I end up with my original polynomial of x squared plus 10x plus 16. Let's check out the second example. This example is a little bit tougher because I've got a negative sign in the mix. I'm now looking for two numbers that when multiplied together get 6 and when added together get negative 5. Let's look at my factors of 6. I've got 1 and 6, 3 and 2, and let's not forget about those negative numbers as well. Negative 1 and negative 6, negative 3 and negative 2. For this problem, it looks like negative 3 and negative 2 are the factors that I need. So I'm going to stick those in here. My two factors are now x minus 3 and x minus 2. Lastly, I'll look at an example when the constant at the end has a negative sign. This time I'm looking for two numbers that multiply to be negative 40 and add up to be 6. So essentially I'm looking for two factors of 40 that have a difference of 6. Let's take a look at the factors of 40. I've got 1 and 40, 2 and 20, 4 and 10. I think we can stop right there because we see 4 and 10 has a difference of 6. Now, when deciding where to put the signs, I always want to put the sign of the middle term with the larger number. So in this case, that would be 10. I want x plus 10 and x minus 4. If you're ever unsure, you can always FOIL to check your answer. Let's be sure on this one. I've got x squared minus 4x plus 10x minus 40. My middle terms simplify, and I get x plus 6x minus 40. Perfect. All the trial and error methods will be basically the same. I'm looking for two numbers that multiply to be the last number and add up to be the middle term. It just takes a little effort. Let's look at the next method. Next method is the difference of squares. The difference of squares is to be used when two perfect squares are being subtracted. This is an easy one. All we need to do is take the square root of the first term and the second term and then alternate the signs in my binomials. So for example, in question number 1, I've got x squared minus 9. The square root of x squared is x. The square root of 9 is 3. I alternate my signs and end up with a final answer of x plus 3, x minus 3. Let's look at the next one. I've got 4x squared minus 25. I take the square root of the first term and I get 2x. I take the square root of the second term and I get 5. And now I alternate my signs. Now you're probably wondering, how does this magic happen? Let's take a look at what happens when I FOIL. I get 2x times 2x, which is 4x squared. I get negative 10x. I get positive 10x. And lastly, I get negative 25. Take a look at what happens with these middle terms. They cancel out and voila, 4x squared minus 25. If you can master the difference of squares method, you can consider yourself a math magician. The last method for today is the perfect squared trinomial. And the perfect squared trinomial method can be used when the first and the last term are both perfect squares. So, for example, question number 1, my first term is x squared, my last term is 49. The square root of x squared is x, the square root of 49 is 7. Perfect, I'm set up for the perfect squared trinomial. All I need to do is keep the sign of the middle term and put the square root of the last term in my box. Now, I can rewrite this as a binomial squared, or x plus 7 squared, because I'm really multiplying the same thing together. Looking at example number 2, I've got 36x squared minus 12x plus 4. I look and I see that the first term is 36, my last term is 4. Both of those are perfect squares. I take the sign of the middle term and I'm going to do 6x for each of the first terms and 2 for my last terms. Again, I get 6x from taking the square root of the first term, and I get 2 from taking the square root of the last term. I can rewrite my two binomials as one binomial squared and write it as 6x minus 2 squared. There you have it. There's 3 wonderful methods for factoring. Now the fun begins. Take some time to practice on your own to master the 3 methods that we've learned today before you come into class tomorrow. Have fun!